Okay, so we're going to talk about, in the first half of today, we're doing all solving. We're going to talk about in the 7-5, how do you do exponential and logarithmic equations. So this first problem goes back to a question in the textbook, but it's real similar to one that you had on the worksheet. When the question asks how much will be in the account after 3 years, we were able to just plug in and figure out the value, right? But specifically, when I asked you all how many years will it take, what were we solving for? We were solving for t, right? The variable up in the exponent t. So how did we solve that?
Just plug in
Right, we plugged in y1, we plugged in the other part into y2, and we found where they intersected on our calculator. Today, I'm going to show you how to actually do this algebraically instead of doing this graphically. So the essential question for today is, how can I more accurately find that variable t without going through the extreme of graphing the exponential function on my calculator using y1, y2 intersect? So that's how we're going to start today. How do we do this algebraically? How do we do this by hand? So we're first going to look at, if you're taking your own notes, subcategory, like the first thing we're going to look at is how do you solve an exponential function? The second half of this lesson, we'll talk about how do you solve a logarithm, but just for the first half, we're going to talk about how do you solve an exponential function. And this first way, we're going to solve without a calculator, and it's called the same base method. We talked about this the other day. Yes, it was on your quiz. All right. So in this problem, it says, what's the solution of 16 to the 3x equals 8? So I'm using the same base method because I can rewrite 16 and 8 in terms of a common base. What would that common base be? 2. So I can rewrite 16 as 2 to the 4th power, and then that's raised to the 3x. How can I rewrite 8? 2 to the 3rd. So let's clean this up a little bit. Power to a power, what do? We multiply. So that would be 2 to the 12x equals 2 to the 3rd. So if I have 2 to the 12x equals 2 to the 3rd, what do I know about 12x and 3? They are equal, that's right. So we would say that this implies that 12x has to equal 3. Solve for x, what do I get? 1/4. How are we doing? Yeah, same base? Got it. All right, let's look at the next one. We got 27 to the 3x equals 81. What's my same base here? 3. Very good. So 27 is 3 to what power? 3 to the 3rd, and then that's raised to the 3x equals, how do I rewrite 81? 3 to the 4th. Right here, power to a power, what do I need to do? Multiply, so that's 3 to the 9x equals 3 to the 4th. I have the same base, and they are equal to each other, so what do I know from here? 9x equals 4. So x equals 4/9. Y'all with me? We literally did this the other day. Yeah, okay. All right, see if y'all can try the bottom one on your own. This one's pretty easy. Once you have your answer, as always, what should you do? Check with a neighbor. Did y'all get 2/5? Yes. Fantastic. Little operations here, but nothing too crazy. Are we okay? Do we feel confident with the same base method? Sort of. What questions do we have? Okay, yeah. You got it, yep. Good things come through practice. Definitely got to practice. All right. second method, okay, when it comes to solving an exponential. What happens if you cannot make them have the same base, okay? So in this next part, your second way, when the bases are not the same, you can solve by taking the log of each side. Why would I take the log? Alex, say that louder. It's the inverse of an exponential, right? It's the inverse. So how do we, like, for example, how do we undo a square root? We square it, right? We do the inverse operation in order to solve. Same thing here. We do the inverse operation in order to solve, okay? But really key here, you might want to make a note to yourself. You have to get the exponent part by itself before you insert the log, okay? So, for example, what do I mean right here? You don't have to write this down. I'm just telling you right here. If I had like 15 to the 3x and then like minus 6 equals 285, is the exponent part by itself? No. What would you have to do first? You'd have to add the 6, then put the log in. Does that, y'all with me on that? Okay? So again, you might want to make a note to yourself. Before you insert the log, you have to get the exponent by itself. So in these two examples here, are the exponent parts already by themselves? Yeah, they are. Okay. So I don't have to do any extra work right now. I can just go ahead and put a log in. So going back to our properties that we talked about yesterday, when I insert a log on both sides, because remember what you do to one side, you gotta do the other, okay? By putting a log in, what happens? Eric, say that louder.
The 3x goes to the
Why?
that's where the exponent goes.
Yeah, it's a power, right? The power property that we learned yesterday says, hey, if you have an exponent, it comes out front. So by putting that log in, I'm able to erase that exponent essentially. So the 3x comes down out front, and you have the log of 15 equals the log of 285. Are y'all with me so far?
Yeah.
Okay. Put a log in, the exponent comes down out front. Now, this is really nice. I'm solving, right? So I'm solving for x. I got to get everything away from x. How do I do that? I'm going to divide. And I'm going to divide by the 3 and the log of 15. Divide it by the 3 times the log of 15. So now, get your calculator, and let's type this in. Eric.
Is it log base 15 or is it log base 10?
It's log base 10. So when you type this in, y'all know like the actual log button that we talked about the other day? Like not the fancy shortcut one. It's the actual log button. I think it's next to number 7. Yeah. If it were me, when I type this in, y'all have that shortcut for the fancy fraction, right? Right? Like I would type this part into my calculator in that fancy fraction. If you don't have the fancy fraction, the alpha y equals, just make sure you use parentheses on the bottom. Okay? What do we come up with, friends? 0.69? Okay. So approximately 0.69? Let's do 0.69. I like that. No. Let's do the hundreds. Okay. Do we understand why we insert the log? It's the inverse of an exponential. So it brings that exponent down out front. Yes, Campbell?
So you're not like making it into a log equation, you're like inserting.
Right, you're just putting the log function in so that way it brings your exponent down. Yeah, the whole point is like to bring that exponent down so you can actually solve. Yeah. Okay. All right, let's look at this next one here. Ask yourself what first? Is the exponent by itself? Is it? Yes. So from here, what do I do to both sides? Log them. Log them. So from here, I would write 2x times the log of 5 equals the log of 130. Again, we're solving, so we got to get everything away from x by dividing by 2 and the log of 5, and we can do that all at one time. On this one, compare with some people around you, okay, before we call out the answer. What you got? 1.5 what? 1.51? All righty. How we doing, friends? All right? Lily.
Why do you put like the 2x on the outside?
It comes down out front, and it acts as if you're multiplying by that.
Okay.
That was a property yesterday. All right. Let's kick this up a notch. How is this different from the last couple? Oh, you know that exponent ain't by itself, right? What do you have to do first? You gotta get the exponent by itself. How do you do that? Divide by 3, yeah. So we have 5 to the x minus 2. Y'all see here, I hated the examples that they did, so I just made up my own.
Yeah.
Those examples.
Don't say it. We on video.
I do not like those examples.
I feel that.
All right, what's 612 divided by 3?
204.
What?
204.
204. Okay, thank you. All right. They were not.
Gotta get that exponent.
All right. The exponent, is it by itself now? Yes, so what can I do to both sides? Log them. Log them. All right. Be extra careful here, guys. You're bringing down the x minus 2 out front times the log of 5 equals the log of 205. Or sorry, 204. Okay. From here, what's my first step? Divide by the log of 5. Why am I not dividing by -2? Yeah, that's with the x, right? It's not all being multiplied in this case. So we got to figure out what is the log of 204 divided by the log of 5. So x minus 2 equals what? 3.30. Now can I solve for x? Yeah, this implies that x equals 5.30. Do y'all see how it's different when you have addition or subtraction in your exponent?
Yes.
Okay, Carson.
Why could you not have added the 2 earlier?
Because it was being multiplied by the log of 5.
Okay.
So you had to divide the log of 5 first and then add the 2 over. Yeah, great question. Anybody else got a question? No. All right. See if y'all can do this one on your own. Bless you. Y'all help me out. What's log of 56 over log of 3? 3 point what?
366. 3.66. I have no idea what it's
Oh my God.
3.66.
3.66, yes? Okay, and then we subtract 4. So what do we get for x?
Negative 0.34.
Negative 0.34. All right. How do we feel about solving exponentials? You got to do it by hand with change of base, right? And then you also know how to do it when they don't have the same base. We feeling good? All right. Eric, question? No. If it's not the same base, you would have a calculator. Yeah. All right. We'll skip that for now. Let's talk about transitioning into solving logs. You already know how to do this, kind of. Solving logs. Logarithmic equations can also be solved many different ways, but you first have to condense. Let me highlight that. Okay. We talked about condensing yesterday because I told you all when you're solving, you have to condense first, okay? It's kind of just like with the exponential that we saw. We wanted to get the exponential by itself, right? We also want to get the logarithm by itself, one single log, okay? Once condensed, it says write it as an exponential. Why would you write a log as an exponential in order to solve? It's the inverse, right? It's the inverse. So, how are we going to change a log into an exponential? Circle trick, that's right, or lack of circle trick because y'all hate that it's not a circle. All right, so last part's really important here also. Check your answers to make sure that they work. We're going to see where some of them don't, and I'll explain why they don't. So in this first problem, what is the solution of log of 4x minus 3 equals 2? If I'm going to use the circle trick, what do I have to have? I got to have a base. Very good, Alex. So what's my base here, guys? 10. So once I have my base, bless you, I can turn this into an exponential using the circle trick. So we would say 10 to the second power equals 4x minus 3. Ooh, the ellipse trick.
The spinning trick.
Oh, we use the ellipse. Yeah, I like the ellipse. I like the ellipse. I like that. All right. Can we simplify from here? Yeah, 10 squared is 100 equals 4x minus 3. Let's solve for x. 103 equals 4x. Divide by 4. Give me the decimal. 575?
It's just
Vinny! Quit feeding me wrong answers. What is it? 25.75.
yes.
All right. Now, here, listen. Here is why you check. Is it possible for us to take the log of a negative number? No. We've talked about this, okay? You cannot take the log of a negative number. So when you plug this number back in, remember how we checked for extraneous solutions that one time? A couple times? It's kind of the same process, right? Plug it back in and see if it works, okay? Now, if you plug in 25.75 for x, this should equal 2 on your calculator, all right? Another way to check is if you plug this in and you get out a negative number right here, guess what? It's not going to work, okay? You automatically know, oh, you can't take the log of a negative number, so I know that that's going to rule out. Does this, in fact, work? Yes, all right, bueno. Plug it back in, make sure it works. Hey.
What would you say? Would you just say no solution?
Yeah, no solution, yeah. Because when you look at the exponential, like if you look at the inverse, right? It never goes to 0. And so when you look at the log, it will never be anything less than or equal to 0. It just can't happen. Okay, here we go. Let's look at another one. Y'all want to try this one on your own?
Yeah.
Yeah. Got
Why
it.
not?
What's the first thing you notice?
Log 10.
Good, Zach. Log base 10. Uh-oh. Exponent is negative.
What's wrong?
Did y'all say 1/10?
Yeah.
That's what I said.
That's what I said.
Yeah, 1/10 is correct. Y'all want to use the fraction?
Yeah. Plug it in
Yeah.
the calculator. A lot easier. Just math it
Yeah,
out.
I would probably use 0.1.
What's your problem?
That's kind of sneaky.
I know, because normally I love fractions. I know. You know.
That's making me mad.
That's messed up.
You can use 1/10. That's fine.
That's what I thought.
Vinny, look at my face.
I'm trying not to
Mhm,
be scared.
mhm.
Negative 2.9.
Negative 2.9 equals negative 2x. X equals negative 1.45. Positive. All right. Oh my gosh. All right. Last thing. What should you do?
Check for the extraneous solution.
Check for the extraneous. Make sure it actually works. Plug in 1.5 for x. See if you actually get negative 1. Yeah, I've said actually a lot. It actually works. Yes. Okay. All right. How are we feeling? Let's kick it up a notch. Because have we condensed on these last two problems? Nope. We're about to, though.
Oh, yeah.
Here we go. It's a snack. We got it. No big deal. Here we go. This is snack, yeah. Snack. Here we go. We're hungry. Yep, need a snack. Here you go. What is the solution of log of x minus 3 plus log of x equals 1? Now, like a red flag is raised here because we see 2 logs. We have to condense first. Okay? What does that plus sign tell me to do? Multiply. So here we go. Hey, we got to get through this. Let's move. So I'm going to multiply the x by the x minus 3. Can I go ahead and do that?
Yeah.
Say x squared minus 3x.
Yeah.
All right, is equal to 1. Okay. Yep, base 10. Now here we go. 10 to the first power equals x squared minus 3x. By condensing, what did I just introduce? A quadratic. So, how do we solve a quadratic? Set it equal to 0, and we're going to factor. That's right. So this means x squared minus 3x minus 10 is equal to 0. What multiplies to give me negative 10, adds to give me negative 3.
Negative 5 and 2.
Negative 5 and positive 2.
That's what we got.
And x equals 0. So this means x could equal 5 or x could equal negative 2, right? Let's look back at our original equation here.
Can't be a
Carson, say that louder.
can't be a negative.
When I look at my solutions here and I go to plug them back in, if I plug in negative 2 for x, I just got done saying you can't take the log of a negative number. So what do we know about negative 2? It's not going to work. Okay? Looking at 5, does it look like it could possibly work? Yeah, you got to plug it in and check.
So you plug it into the original problem?
The very original. Yes, it works. So that's what I was talking about with these solutions. Some of the times you can tell right off the bat if they're not going to work. Okay? Other times you might want to plug it in, just double check. Okay? Y'all with me? We're not getting away from quadratics. They still keep showing up. Yep. All right. Let's look at the next one. Go ahead and write it down. Let's talk it out. What does that minus sign tell me to do? Divide. Let's go ahead and put in log base 10. That'll save me a step. 6 over 3x equals negative 2. Now, this one's a little tricky. And I want you to think. 10 to the negative 2 equals 6 over 3x. Would it make sense to use the fraction here or the decimal here?
Fraction.
The other side is a fraction, so I would keep it as a fraction. So we would have, this implies 1 over 100, right, equals 6 over 3x. When you have two fractions equal to each other, what do? Cross multiplies.
The butterfly.
Oh my gosh, the butterfly has actually shown up. So we have 3x equals 600. So what does x equal? 200? Right off the bat, does it look like it would turn out nicely? It looks like it'd turn out nicely. You might want to plug it in and check, though. It could not work, and your answer could be no solution. I don't know. Campbell says it works. Can I get a confirmation? Sydney says it works. Let's get another one.
Yo, Campbell. It works.
It works? All right. Questions over solving with condensing. What does silence mean to me? That you understand. Do we understand? All right. Nope, already did those. Do y'all want to keep trying this? You got it? If you want to try these, you can go ahead and take a picture. A lot of you all have been asking me, like, I don't really know how to study for this test or like the quiz, which I will get back to you all tomorrow. But like a lot of you are asking, like, I don't even know like where to start practicing. Right here, okay? If you want to take a picture of these and work them out and practice them, I'd be more than happy to check them for you during our review day tomorrow, before school tomorrow, anytime. So I would take a picture of them, practice, see if you can do what you were supposed to do today. These are solving logs, specifically logs. I feel like y'all have the most trouble with logs. Exponentials you're pretty good at. Again, more practice. Do we want to practice a little bit more?
Yeah.
Y'all want to do these? No.
Do two.
Two of them? Let's do the exponential one, but what other log one would you want to do?
None of the bottom one. Let's just do
65?
Why'd you say
yes? Yes.
65 looks a little rough. All right, let's do these two, and it's our last slide.
And then break time.
And then we'll take a break. Yeah, we'll take a break. So we'll do a log, and then we'll finish up with an exponential. Make sure you know what you're doing. All right, here we go. Walk me through this. Help me out here. Condense. 65 first.
Log of 4x. Or base 10, sorry. Log of base 10, 4x to the 1/2 power.
The 4 and the x are both getting the 1/2 power?
No,
Oh, just the x. Okay.
Wow.
Equals 2. Can I rewrite that 1/2 power as what? Square root. Yeah, 4 square roots of x equals 2. That'd be a lot nicer. What do I do from here? Circle. 10 to the second equals 4 square roots of x. So 100 equals 4 square roots of x. Divide by 4, running into the bottom. 25 equals the square root of x. What do I do to solve for x? Square both sides. Good, Lily. What does x equal? 625. wasn't bad. Yeah, the question is, does it work? Let's plug it back into our original equation. Let's see if it works. No? I need 2 other people to confirm it.
Yes, it works.
You proved it? Don't just say yes. I know what your game is. I know what your game is. It works. All right. Last problem, then we'll take a break. Here we go. Let's go back to what we started with at the beginning of the day. 12 to the 4 minus x equals 20. Okay, so let's ask ourselves a new question. I know, right? Can we do the same base method here? Can 12 and 20 be rewritten as a base with a power? The same base. Not with the same base. Can't happen. So we got to put a log in. That's right. Log them. Now, before you log them, did you check to make sure your exponent was by itself? Of course you did. Of course you did. So we got 4 minus x times the log of 12 equals the log of 20. Help me out. Divide by log of 12. So I have 4 minus x equals what? 1.28.
That's a 0. It looks like an 8.
Somebody help me. What? 1.21.
Yes.
All right. What do I do from here? Subtract 4. So what do I get? Negative x equals
Whoa, you gotta bring the negative from that x.
negative 2.79. So that means x equals 2.79. All right. We are going to take a 4-minute break. During the break, make sure you grab the 7.5 worksheet. 7.5 worksheet.